Okay, so here is a little story about quadrilaterals. Or a little lesson, sorry, quadrilaterals. So all a quadrilateral is any polygon with 4 sides. Okay, so it is a convex, is what we're going to talk about, polygon with 4 sides. Okay, convex is just a shape you know. A difference might be this is a concave shape. Okay, so this one is concave, and we're not going to talk about concave shapes. The way to think about concave is there's a little cave, but we're not going to think about those. We're just going to think about convex, which is the opposite. No cave is the easiest way. Convex, not a word you need to know. So anyway, anything you want to draw with 4 sides. Okay. We also have some special quadrilaterals. One of them is a parallelogram. And what a parallelogram is, I'm going to write the definition and then have you draw it. Okay. Parallelogram is a quadrilateral with 2 pairs of opposite sides parallel. Okay. So take a minute and draw a parallelogram. Okay, so here is what hopefully you drew. Something along these lines. It's a terrible drawing, I know. But these lines are parallel. And these lines are parallel. Okay? Right? You've seen parallelograms before. Okay? So that's all a parallelogram is. What's really important is that you have this definition. Okay, a quadrilateral with 2 pairs of opposite sides. Okay, the next one is a rectangle, and I know you all know what a rectangle is from elementary school. What's important to know is a rectangle is also a parallelogram. Okay, and we're going to prove that. So the definition of a rectangle is a quadrilateral with 4 right angles. That's all it is. Okay, so if I draw that, right, and I say, hey, I got 4 right angles. I want to prove that that's a parallelogram. Okay, so what I know is that angle A, angle B, angle C, and angle D are right. That's given, right? That's what I get from having a rectangle. So that means that angle A, angle B, angle C, and angle D all equal 90, because that's the definition of a right angle. Okay. So now I would like you to pause and think about how we might prove this to be a parallelogram. Okay, so hopefully you've thought about that. So this is how we're going to do it. Is we're going to say A and B equal 180 because of addition. And we're also going to say that B and C equal 180 because of addition. Right? This is just addition property. Because 90 plus 90 is 180. Which then means that line AB is parallel to line CD. And line BC, segment BC is parallel to segment AD because same side interior angles are supplementary. Same side interior angles are supplementary. Okay? And if opposite sides are parallel, it's a parallelogram. That's a definition. So we can say ABCD is a parallelogram because opposite sides are parallel. Okay, so now we know rectangle is a quadrilateral with 4 right angles, which means it's also a parallelogram. Okay, the next shape we have is a rhombus. And what a rhombus is, okay, is a quadrilateral with 4 congruent sides. Okay, and I'm going to tell you it is also a parallelogram. So if we draw a rhombus, okay, and we know all of these are equal, right? then what we want to also prove that this is a parallelogram. Okay, so here we're going to start proving stuff. So what we're given is AB is congruent to BC is congruent to CD is congruent to AD. Great. So we have this, this is given because it's a rhombus. All sides are congruent. So to prove this, it's a little bit trickier. I'm going to draw in this transversal, and I'm going to say that AC is equal to AC reflexive. Okay, so what I now know is that triangle ABC is congruent to triangle ADC by side, side, side. Okay, so pause this to take a moment to prove, see if you can prove that this is a parallelogram. Okay, so if you did that, and first I need to fix, this should be ABC, this would be CDA for what I want to do. So now I'm going to number these angles to make my life a little bit easier, and I can say, hey, angle 1 is equal to angle 3, and angle 2 is equal to angle 4, CPCTC, right? Which then means, right, that AB is parallel to CD, and BC is parallel to AD because alternate interior angles are congruent. Which then means that ABCD is a parallelogram because opposite sides congruent. Or parallel, sorry. Okay, so now we have this rhombus, which is also a parallelogram. Okay, the next shape we have is simply a square. And a square, that we don't have a proof, is a regular quadrilateral. Regular quadrilateral. And a regular means equilateral and equiangular. Okay, what's important now to know is a square is all of these things. It's a rectangle because it has 4 right angles. It's a rhombus because all sides are the same. And since it's these guys, it's also a parallelogram. So hopefully you see this little hierarchy. Okay. And then our final quadrilaterals we're going to talk about are trapezoids. So all a trapezoid is a quadrilateral with one pair of opposite sides. Okay, so that is like this. If these are parallel, right? There's a quadrilateral. And an isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. Okay, so if this is our shape and these are parallel, so we have a trapezoid and these are equal. Okay, a trapezoid, let's add on to here with exactly. Because of both pairs, it's a parallelogram. Okay, so those are all our shapes, all our quadrilaterals that we're worried about today. This video is a good one to go back to remember how to prove something is a parallelogram.